This differential equation is a little worse than the last one, and we're going to see some more interesting behavior than the last one. Let's go ahead and get started. So first we need to get this into the correct form. We need to find p of x and g of x. So to do that, we're going to divide by x squared minus 25 everywhere. So you end up with y prime plus 1 over x squared minus 25 times y equals 0. So then the p of x is 1 over x squared minus 25, and g of x equals 0. So we have discontinuities at x is equal to positive and negative 5. Because in either of those cases, we get 25 minus 25, we get division by 0. All right, so then that splits up the x ranges into, or the x intervals into 3. So we have negative infinity to the first discontinuity, negative 5. Then we have negative 5 to 5. And we have 5 to positive infinity. And here's what it ends up looking like. So it has some interesting behavior. So to do this, it's going to have 2 points at x, but it's going to have some interesting behavior. So I'm just going to draw, and I can draw the y-axis. All right. And we'll have x equals, so I'm going to put this down here because it's going to get a little crowded around that point. So negative 5, and how far away is that? About there, I don't know, positive 5. So in here, what ends up happening is everything that starts to the left of negative 5 ends up going towards 0 at negative 5. So it does kind of this and this. I did that sort of well. Let me start here. All right, there we go. And then same thing on the bottom. On the other side, it's also all going towards the point negative 5 comma 0, but then over here it's going like a vertical asymptote, so something like that. Let me do they aren't so exaggerated, and I need some room, so let me just try this. All right. Something like those. Then to kind of get them to fit together, and they should be getting pretty vertical when they get there. All right. And to get there, this one on the right is still going down, so it does something like this on each of these. So this one will be up and then down. That's not supposed to inflect. Let me do the top ones first, instead of trying to switch. It's confusing me. Okay. And these ones are going to down, and that's too much. Down, 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 and down. All right, something like that. So this one is a vertical asymptote. But this one actually, this thing at negative 5 isn't. So if you solve this differential equation, you can do it. It's very annoying. You have to do, it's a separable equation, but then you have to do partial fraction decomposition for the x interval. What you end up with is y of x equals a constant times the absolute value of x plus 5 over x minus 5 to the 1/10th power. So in here, when x is getting closer and closer to positive 5, we end up with about 5 plus 5 on the top, so it's about 10. So that's a reasonable size number when we're near x is positive 5. But on the bottom, we end up with approximately 5 minus 5. So we get this really, really, really small number, and it's either really negative or really positive, depending on which side we're on, and then the c flips it around. But that's it. So, right, we're getting essentially 10 divided by a really, really small number. A normal size number divided by a really, really, really small number ends up making a really, really big number. So that's why it's going to positive and negative infinity in y when x is positive 5. But when x is negative 5, we end up with an about. So we get about negative 5 minus 5. Well, it's about negative 10 on the bottom. So you don't have a division by 0 problem. But on the top, we have about negative 5 plus 5. That's about 0. And as x goes to negative 5, the whole top just becomes 0, and the bottom becomes negative 10. And so in there, these things aren't doing a vertical asymptote. They're actually going to that point, every single one. is actually getting there. It goes through negative 5, 5. Didn't draw that one that well, but here we go. The other thing is the slope at this point actually won't be infinity. It's going to be some number. So over here, right, there's a jump discontinuity. If you cross that, it looks like your solution, isn't going to connect. It's going to be discontinuous. Over here, there is a problem occurring right there. But you can kind of, if you follow in one solution, it's going to have a slope actually when it reaches here. You could follow out a solution with the same slope, and you could actually kind of piece together something that passes through here. And so that's the idea. So this one is more interesting. They're not actually getting vertical, right? If you take the derivative of this, as you're getting closer and closer to x is equal to negative 5, you're not going to have an infinite slope. It does get quite steep, but you won't. And then you can actually pick kind of the slope that comes in on one side. So kind of as an exaggeration, let me see if I can do it here. I could have something going in like that, and then it comes out with the same slope, and then it goes over this other one and goes up to positive infinity. But yeah, so this is how we can find intervals of validity for first order linear difference equations. It's a lot easier than for nonlinear. We'll see that in a moment, because we only have to worry about the discontinuities p of x and g of x. And sometimes you can repair them, but you do have this problem where y prime has to be defined there, and you have to check it all works out and all that fun stuff.